Welcome back, ladies and gentlemen. It's Benedict here again from Jacking and Company Associates, and I want us to continue from where we stopped last time. And last time we were trying to code how we can remove the leading and lagging spaces, and we had done a code and we started with creating a variable called calls, which we said that calls is equal to data1 dot select underscore d types, then in bracket object, then dot columns. Then in the second line of that code we wrote that data1 in bracket calls is equal to data1 bracket calls dot apply lambda. And then when we are trying to apply lambda, instead of using the parentheses, we used square brackets. So what we'll do here, we'll just change the square brackets into parentheses, and then again try to run the code and see if it will run as is expected. So here we'll try to run to print data1. So today the data is running. So again, instead of we need to move on, but instead of using data1, I want to change data1 to data again. So what I will do here, I will do away with not do away with, but I will change data1 to data. So I will say data is equal to data1. Instead of writing data is equal to data1, we just change it up here. So here we'll write data is equal to pd.data frame in bracket data1. So I know understand how we use variables such that when we say v is equal to 3 3 plus maybe x. Let me start with x. So I can say x is equal to 3. And again we are saying v is equal to 2 plus x. And then we can again come down here and say x is equal to 6. So now when we print x, instead of getting 3 we'll get 6, but initial x was 3 because the variable has been changed from the value 3 to 6. So like now when I print v, so first I will use v when x is 3, so I will comment out this x. So when I put v, let me comment out data1 also. So when I print v, it's asking for, you can see v is 5. So there's a code running down here. Let me just try to comment that code. We'll come to that when we are moving to the next step. So let me run this code again. Okay, financial is not defined, so there's an error with the code down here. Again, let me try to comment this out. So this will come to when we are doing the period variables. Let me try to comment it out up to here. I just want to do away with the period 1 on the right. So let me try to run the code again. So the code is not running. Instead, we are getting an error because of how I've commented out. So let me just try to avoid the errors. So what I will do, I will just uncomment this one out to avoid the errors. So I don't pay attention to what these values will ask, what the variables will ask for the user to enter, but just concentrate on the variable called v. So we want to print the variable called v. So here we have v is equal to 5, meaning v is equal to 2 plus the value of x, which is 3. So when I uncomment this other value here, this variable x again to 6, so you'll expect v to be equal to 2 plus 6, which should be 8. Let me run this again. It's still 8 instead of 6. Let me try to run it again. It cannot come 6 because the value v is running before the next variable x, which is equal to 6. So when I put the variable v down here now, instead of copying, let me just undo and print it down here. So now when I print v should be 8. Yes, now the value the variable called v, the value of the variable called v is 8, because the variable x has changed from 3 to the value 6. So just trying to show you how we've used the variable data 1 here, because we started with data up here, started with data, and then we also changed this data to we coded this data to in various forms, and this data now was equivalent to data frame that we had replaced the closing stock with current assets. But now down here we are changing this data to the data that we just concatenated. We concatenated this data here and called it data 1. We call it variable, we named the variable 1, and then we concatenated the data frames. And then this data 1 is now what we're changing to data. So the data up there, the variable called data up there in the initial stages has changed to the value has changed to a new value, of which is the concatenated data frames of TB1, TB2, TB3, TB4 that v. So let's move on. You say that from here we need to move on to creating variables for financial year, for current financial year. So we said that we'll move to step 2, where step 2 will create variables for the current periods and prior periods. So we'll start with the variables for current period, then we'll move to prior periods. So before we start creating variables for the current period, I want us to rather create a code that will make sure that we have the columns, the maximum columns, and then again the numerical variables, we want to see them in two decimal places. So down here I have two codes for display of decimal places, two decimal places, and then also having the maximum value of columns. So I'll just copy this. Let me just cut instead. Then I will want to put it up here. So I will uncomment this one. So I want maximum columns, and then the maximum columns here should be around 10, and then the decimal places should be two decimal places. So now when I print that data instead of data 1, when I print data now, it will be how it appears. So let me run this again. And the PC is a bit slow, but now you can see now we have all the columns from financial year, quarter, month, period, PBI time, category, ledger, the sub ledger, and the value. But now we have them. We have the values with two decimal places, and on the left hand side we have all the numerical values before the decimal place. So let's move on to our next step. So let me just do away with this printing of it. So before we create variables for the current financial year, we need to create variables for user input, where the user will input the values for period, and then the values also for financial year. Remember, the period here we are talking about monthly periods. So we said that within our data frame you are saying that our January is period 1, and then February is period 2, but when your period starts from March or maybe June, so your first period will be 1 for March, and then the second period will be period 2, April. But let me again just try to print let me open the Excel workbook. This will be referring to it from time to time. Again, before we move to creating variables of current period and prior periods, I also want to mention that the figures here that you are seeing on this Excel sheet for YTD and volume are not volume per se, but YTD are cumulative in nature. So when we move to the financial year for 2017, when we move to 2017, January will be the figures for January will be monthly. At the same time, they'll be cumulative for monthly for the period of January. So when we go to February again, let me just try to filter out other periods. So when we go to February, the cumulative figures for February will be including the monthly figures for January and February. So when we are creating our variables, we'll have monthly figures and cumulative figures as at a certain period. Like now, if we create the variables for February, we'll have monthly figures for February, and then also have the cumulative figures for February. such that when we run our income statement, we'll have monthly figures, and then we'll also having cumulative figures. Then balance sheet and cash flow are always cumulative in nature. So we'll be using cumulative figures to calculate the balance sheet and cash flow. So let me take you back to where we are doing our code. So down here we are saying that we have two variables. First variable here is let me try to. For the first variable here we have period, and then we are saying period number is equal to integer in bracket input. Then we are telling user to enter the period number. So the period number can be 1, can be 2, can be 3, up to 12. And then we also have financial year. So the financial year, again, we are telling the user to input an integer, which can be 2017, 2016, or whichever period depending on your financial data. So that's why we are saying here period number is equal to integer input, enter period number. Again, financial year is equal to integer input, enter financial year. So when I run my code down here, let me just try to run the code. So now you can see we are being asked period number. So I can say 1 to mean January. So when I enter, it will ask me again the financial year. So I will try to put 2017. And now you can see this the data frame for the year 2017 February. So when we come down here again, we need to create more variables. So the variables that we need to create, we'll put them within functions. So we'll work with a function. I will just have we'll have functions within function, but when we run our code, we'll be calling this function to run our financials. So the function here we are calling it def main in brackets. Then we are starting with the year input, and the year input is just financial year. So the period number and the financial year are global variables, so we can access them within this function. So again, we are saying year input is equal to financial year, which is up here, and then the pre-year one input means the prior period. So the prior year, the first prior year. So for example, when this year is 2018, so the prior period 1 will be 2017, and the prior period 2 will be 2016. So we are saying prior period 1, which is pre-year 1 input, is equal to year input minus 1. So the current year is 2018. So when we minus 1 from the 2018, we'll get 2017. When we want 2016, we'll minus 2 from 2018, then we'll get 2016. So these are the prior periods for comparative figures. So these are variables we'll use when we are calculating balance sheet and cash flow. So let's go to current financial year variables. So when we go to current financial year variables, which are here, so these are my current financial year variables. So we'll have cumulative sum as a variable. We'll also have monthly figures as a variable. We'll have asset variables. So here where I'm writing monthly figure should be monthly variables, and then also we'll have variables for assets. I will also have variables for loan and investments. and then we'll also have variables for opening and closing stock. Remember, opening and closing stock, we'll use it when we are trying to calculate the performance of a particular period. I mean income statement. So we'll create all these variables for each and every period for current financial year, then for prior financial year, and then we'll also have variables for budget so that we can compare the actual figures with the budget. So when we start with the January variables, let me try to draw this one down here. So in January variables, we have a variable here called so we have this variable called Jan underscore CumSum. So CumSum here just means cumulative sum, and then we are trying to select a set of data within period 1 and the year input. So the year input can be 2016, 2017. The period 1 year means that we are trying to get a subset of data for period 1, for period of January. Then we'll also try to rename the columns. So the columns here, we are trying to say the value, and the value should be equal to YTD actual. So these are numerical values, and then we are dropping financial year, we are dropping quarter 1, dropping month, we are dropping period, and TB item. So we are only trying to remain with the category, ledger and sub-ledger, and then the column for numerical figures, of which we've renamed YTD actual. So again, now we have another cumulative figure, and this other cumulative figure is for cash flow. So this one I'm writing here, Jan CumSum underscore F, and the underscore CF is cash flow. So again, we are using the same principle we've used here, but we are having a subset of data for the period January, but now we are not dropping the financial year. We are only dropping quarter, month, and TB item. So the financial year and the period we'll use them when we are calculating the cash flow. So that's why I've not dropped the financial year column, the period. But the same principle I've used here for Jan cumulative sum is the same principle we are using for Jan cumulative sum underscore CF. So when we come down here again, let me try to just print Jan cumulative sum. Is the figure down here? Is the data frame that has been printed down here? So let me just try to period 1. Then the year should be 2017. So this is the data frame for the period January for 2017. See, now we have category, we have a ledger, and then we also have sub-ledger and YTD actual. So the column named value or the label value we had renamed to YTD actual. So again, when we move down now, we have the, let me try to delete this one here and this printout. So down here now we have the variable for January monthly. So this is the variable for January monthly. So here we are saying that January monthly is equal to a subset data of which the financial year is the year input, and then the period is equal to 1. And then when you check this one, January monthly is the same as this one, January cumulative sum. This one being that within the period of January, there's no other prior month, because our financial year is starting from January. So when we are within the period of January, cumulative sum variable will be the same as the cumulative will be same as the variable for January monthly. Then we also have a variable here for data assets. So these are the assets that we bought within the month of January. So we are seeing that data assets is equal to subset of data where financial year is equal to the year input. Then the data assets are within the period of January. Then again we are trying to rename the columns. So the value here has been changed to YTD actual. So the actual period that we are analyzing or reviewing. Then we are dropping the financial year, quarter, month, period, cost, cumulative dip, and the net book value columns. And then the axis, of course, is equal to 1 because we are dropping the columns. So when I take you back to this Excel, when I show you here the asset changes, you can see we have these columns for financial year, quarter, month, period, category, ledger, sub-ledger, cost, cumulative dip, and net book value. So these columns have been dropped. The cost column and the cost column, cumulative dip, and net book value has been dropped. Then we'll also drop the financial year, month, and period. Then this value here has been changed to YTD actual because we are dealing with the actual figures within that period. So let me take you back to our code again. And then after the set data 1, so data 1 here means we are dealing with the period 1, which is January. So after set data 1, we have loan and investments. So under loan and investment, we are also doing the same principle that we used up here. So this is loan and investment 1, which means the period is 1. The period is January. And then the subset data is for the year input and the period 1. Then again, we are trying to rename the columns, the column called value, the column labeled value with YTD actual, and then we are dropping these columns: financial year, quarter, month, period, cost, adjustment, and net book value. So these are the columns that we have within our Excel workbook, and then we are using axis is equal to 1 because we are dropping columns. And then from here now we'll move to opening stock. So when you come down here, we have opening stock for January. We have opening stock for monthly, and we also have opening stock for cumulative figures. So when we see the opening stock for the month of January and opening stock for cumulative figures for that period of January, the figures will be same. What differs is only the names of the variables, but data frames will be same because it is the same period January that we are doing the cumulative figure, and then we are also doing the monthly figures. So the values, the data frame will be the same. What differs is only the variable name. So again, let's move on to closing stock. So when you move to closing stock, also we'll have Before we move to closing stock, let me mention something. So here we have it's okay, let's move to closing stock. So closing stock, we are saying CS to mean closing stock January monthly is equal to this subset of data where we are saying that ledger is equal to closing stock. Remember, closing stock, we had changed the category. Within the column of category, the rows that were showing closing stock, we changed them to current assets. So we are using the ledger column, where the ledger column is equal to closing stock. So when I take you back to our Excel here, you can see YTD sheet. Under category here, you can see down here our closing stock is was changed to, rather within the data frame, we changed the closing stock to current assets, but within the YTD Excel sheet is still closing stock. But within the ledger here, we are saying that the ledger should be equivalent to closing stock. So let me take you back to our Python code. So we are saying here that closing stock, we are selecting that subset of data, and then we are putting that data into a data frame. So we are saying that CS January monthly, of which this is the subset of data that we've selected here. Then now we are trying to put this data into data frame, and then again we are saying the CS January monthly dot log closing stock is equal to CS Jan monthly Jan actual dot sum. So we want to get the sum of the rows that are having the closing stock. So when we get the sum of those rows that we have the closing stock, so we'll use the last row, so which will come as the tail of that data frame. So let me just try to show you what I mean here. So down here, let me come here first and let me print CS and monthly, see how it appears. So we must put the period, so period 1, and we also have to put the financial year, which is 2017. It can as well be 2016, but 2016 is starting from December. So when I print this one, you can see this is what we have as so this is what we have as closing stock. So down here, what I'm trying to do after this code here for printing the data frame for January monthly closing stock, here we are trying to get the total of these figures here. So what we are doing here, we are saying that this code, we are trying to say that we want to add the values that we have here for closing stock. So again, when I print closing stock monthly, CS monthly, so let me do away with this one. You'll see what I have as the data frame for closing stock. The period is 1, the year in review is 2017. So down here you can see we have closing stock. So these are not a number of values. Then we have the total figure for closing stock down here, 957 on 51.65. And again down here we are saying again that so let me delete this. I hope you've seen what the code is trying to do. So let me try to reduce the space. So down here we are trying to, when you see the code is saying that CS and monthly is equal to PT data frame. So we are trying to put this one into data frame, but already it's not data frame. So we are trying to put this variable up here into a data frame, and then after putting into a data frame, again we are trying to replace this total number of values here. We are trying to replace them here with the, let me just try to highlight it first. So here you can see we have a code here for replace. So we are trying to replace the null values or not a number values with closing stock, and again we are putting it in a data frame. Okay, so it's being put in a data frame here. Let me change this to different color. We are putting this in a data frame. See here, being put in a data frame, and again from that data frame we are picking the last row. So that's why we are calling this one dot tail. When we call dot tail, it means that we want the tailing rows, the last row, and then we are writing one to mean the last row. So here we have tail, and then again we are saying reset index. So we are trying to put the index here. This index we want to reorder them, so we are using this word reset underscore index. Then the resetting index, again we are trying to drop an index. So let me just try to print before we take the tailing row. Let me just bring this one down here. So here we'll say CS done is equal to CS done monthly dot tail. CS done monthly dot tail, and let me remove this one here. Okay. This should come here. And then you must use the proper indent. So now it's okay. Now when I try to print closing stock monthly, you'll see what we have. So period 1, then the year is 2017. So now you can see after replacing the null values with closing stock. So where there we had the null values, you can see we have closing stock, and the value figure. So when we say reset index, what we are trying to reset, we are trying to reset this index column. We want to reset this index column to read from 0, 1 to up to the last row. So down here again, let me try to let me try to show you this again. So here we'll pick this January monthly, drop enter is equal to CS and monthly dot tail. Instead of tail, I'll say dot reset underscore index. So let me do away with these two. Look at this. This one I'll put down here. So this was just a code that it was quite lines. There are quite numerous line of codes that were put into one line of code. So here we log in, say CS monthly. So now it's not reset index, it is now drop index. So down here, let me try. So let me do away with this one. I can cut, then I'll put it down here. So now when I print, you'll see what we have as a variable for closing stock January monthly. So period is 1, then the year is 2017. Now you can see that we've only picked at the last row of the closing stock. So this is the value that we want to use when we are calculating our income statement. So we are just picking this value as closing stock. The same applies when we'll be calculating, or rather when we are generating our balance sheet. We'll only be picking this last row, and that there is a value of the summation of the closing stock values. So again, when I come down here, you see now I'm trying to reset index. So let me cut this, and I'll put it down here. After resetting index, we'll see how it looks. Print. So the period is 1 and the year is 2017. So now you see after resetting the index, you see the index column here is 0. And then we also have another column here called index. So that's why we have another variable down here called csjan is equal to csjan monthly dot drop index x is equal to 1. So we want to drop this index again, this index column. So I'll again add this one and then put it down here, then print. It's a bit slow. So the period is 1 and the financial year is 2017. So when I enter now, you can see we have a category, ledger, subledger, and an actual columns. We don't have that index column again. And then we also have this other index column starting with 0. So the original, let me take it back to the original code that we had all this in one line. Just take this one back. We're just trying to show you what happens in that one line of code. So this is what we had initially as one line of code that I've just shown you in different line of code. So again, after doing the sorry, after doing the January closing stock for January monthly, we also need to do the closing stock for cumulative sum. But now this one, the value will remain the same because the cumulative sum for the month of January is the same as the cumulative sum for the month of January still. So when we go to now the numerical value column will be having YTD actual. So what I mean here is that when we are calculating our income statement, we'll be having the actual period. We'll compare that actual period with the budget. Then again, we'll also be having cumulative figure, which is an actual period. And then we'll also have cumulative figure for the budget. So we'll compare the two. Then we'll also have the prior period figures that will compare with the monthly figure and the cumulative sum. So since this one is January, the values will remain the same because the same figures for January monthly will be the same figures for January cumulative sum. So down here we are trying to say that Jan cumulative sum, this one here. Let me just try to reduce it a bit. So down here we are saying Jan cumulative sum is equal to period or data frame. So whatever we are trying to put down in a data frame, so is this data here. So this is what we are trying to put in data frame, and after putting it in data frame, so we are trying to add we've added them up here. So remember the same principle that we used in calculating or coming up with the closing figures for January monthly. It's the same principle that we are trying to use to come up with the figures for January cumulative sums. You can see here we have Jan cumulative sum dot log is equal to Jan cumulative sum, then YTD actual dot sum. So when we are summing here to get the total figures for closing stock, then down here we are trying to get the last row. So we are saying dot tail, and then we are trying to reset index. So when we reset index, we'll have another column for index, and then we'll also have the index column starting with 0 and all those values. Then again we'll drop that index column. That's why we are saying drop index, and the axis is equal to 1 because we are dealing with columns. So after dealing with the January, now we need to deal with the same principle that we applied when we are creating the variables for January. It's the same principle that you want to use when you want to create the variables for February. So already we have a code down here, so I will just uncomment it out so that we can see how we can go about the February variables. So I will only comment out March. So first, now we are dealing with February. Now you want to see how we'll deal with February as opposed to how we dealt with January. But the principle will be the same. There will only be some few changes. So we are saying here the first variable here is January cumulative sum, which is equal to, and the data set with the year input, and the period is equal to 2. So 2 here means February. Then again we are trying to drop, we are dropping the columns for quarter, financial year, month, period, PB item, and the axis is 1. And then when we go to February cumulative sum underscore CF, so underscore CF, we mean that we are now creating a variable for the cash flow. So it's the same principle that we used up, but now we are not dropping the or rather the financial year, because we'll use that financial year part when we are calculating the cash flow figures. Here we just use the same principle that we used up there, but we are only trying to drop the quarter, month, period, and TB item. But the period now is 2, meaning we are in February. And then when we go to data assets, down here we have here data assets 2 to mean the assets for both within the period 2 inclusive of January. So these are the assets which were bought as at the month of February. So we have data assets with the year input being that year that we'll choose as the review year, and then the period year is less than or equal to 2. Remember we are using this less than or equal to 2, mean that we want to pick the values for January and February, because when we go to Excel workbook, let me just take you back to Excel workbook, data changes. So here you see we have monthly figures, we have January, February, March, and then the period here we have also monthly periods. But when we choose period 2, it means that when we choose period 2 within our code, we'll use less than or equal to period 2, because we also want to choose the period 1. So when we choose less than or equal to period 2, it means that the data will pick, or rather the code will pick the period for January and February. So this will apply to all the periods as we move on up to December. So when we choose negative, rather when we choose less than or equal to 12, means the code will be picking all the periods from January up to December, as opposed to just December alone. So when we are back here, let's move on. So here we are saying period is equal to less than or equal to 2, because we want to pick the data assets within January and February. So again, we also have loan and investment. So the same principle applies to loan and investment as well. Because when I take you back to loan and investments, we also have within the period 1 or whichever period, we had monthly figures. So when you want to have cumulative figures for within a period, we'll use less than or equal to. Like now, when we pick period 2, it will be less than or equal to 2, mean that we want to pick all the share capital or all the loans or all the debt payment that were paid within period 1 or period 2, rather all the values that were rather all the loans or all the debt payment that were done within January and February. So we'll take less than or equal to. So when we go back to this code, so you can see here we are saying that loan underscore investment to mean February, is equal to the data set for that year input, and then the period here is less than or equal to 2. If we pick is equal to 2, it means that we are only taking the loans and investments that were done within the month of February. But when we want for the month for January and February as well, we must use less than or equal to. So these were cumulative sum. So let's go to February monthly. So February monthly, you can see the figures here. These are February monthly. So in February monthly, you can see now we are having a different code. So we are saying the first variable here we have February monthly, okay, is equal to PD concat, January cumulative sum, and February cumulative sum. Remember the cumulative sum for January is up here. This is the January cumulative sum. This one here is January cumulative sum. So when you come down here, you also have this one for February cumulative sum. February cumulative sum is what we've just explained is up here. So when we come to this code down here, what we mean here is that let me do here. We are picking pd.concat, so we want to concatenate the two data frames for January and February. Then we are concatenating them horizontally, meaning across. We are concatenating the data frames from left to right. So we are picking January cumulative sum and February cumulative sum. So we want to have two columns. So two columns with values for January and February cumulative sum. And then we are using index is equal to true, meaning we are concatenating them across horizontally. Then sort is equal to false. We are not sorting the data frames. And then when down here we are saying Feb monthly is equal to Feb monthly dot group by. We want to group by category and ledger, and then we want to sum the groups, because we have a lot of groups where groupings within Feb cumulative sum and January cumulative sum. So we want to add such kind of groups together. Then we'll reset index. So before then, let me just try to show you how the data frame looks. So let me come down here and print. I want to print Feb monthly. The period here now is period is 2, because we are dealing with February. Then the year is 2017. Now you can see we have two columns for values. One is this one for written value. The other one is written YTD actual. The YTD actual is this one is coming from January, and this one for value is coming from February. So we have concatenated two data frames, one for February and the other one is for January. So when we come down here, we are saying that Feb monthly is equal to Feb monthly dot group by category is category ledger dot sum, then reset index. Let me print this one down here again, just to show you what happens when I come down here. And again I run this code. So this one is period 2 and the year is 2017. When we run now, you can see we have YTD actual here, and then when we come down here we have also value. Okay, so here we've grouped the category. We've also grouped the ledger items. So let me again come here, group this and put this up here. I want you to see the difference. So we'll have two data frames, the one that has been grouped by and the one that has not been grouped by. So the period is 2 and the financial year is 2017. So when we come up here, we have this data frame first. This one is having value and YTD. This one has not been grouped. So when you check, you can see you have sales volume, and then when you come down here again, the data frame has been freezed because it cannot show the data frame in totality, but we have all the columns. The rows have been frozen, so this has not been grouped. One up here, it is up to here, this data frame. Then down here again we have another data frame, so you can see this one we are having TD actual again, and this other side we also have value. But now when you check the grouping, now you see we cannot see those the not a number values that we had initially in this other data frame. In this data frame we have not a number in this column, and we also have not a number in this other column. After grouping down here, we don't have not a number within the data frame. So again, let me do away with this first print out. So here again we've also reset the index. The index is reading from 0 to 35, so meaning we have 35 rows. On the upper one we have 220 rows, meaning the data has not been grouped. So a minute. Again, when we come down here now, we are saying that now we want to have one rather we want to get the monthly figures. So getting the monthly figures means that we must subtract the cumulative values for January from the cumulative value for month of February. So that's why we are saying here Feb monthly 1, so this is another variable, is equal to Feb monthly value minus Feb monthly YTD actual. Remember, the YTD actual is the value for January cumulative, and this one for value is the this one monthly Feb monthly value is the value for Feb cumulative. So when we subtract two values, we'll get the value for January monthly. So So let me try to repeat again. So we are trying to subtract, or rather after concatenating the January cumulative sum and February cumulative sum, we are trying to get the difference between February figures and January figures to get the monthly figures for February, or rather the monthly data for February. That's why we have Feb monthly 1 is equal to Feb monthly value minus Feb monthly YTD actual. So the YTD actual here, these figures are coming from the January cumulative figures. So down here we are saying that Feb monthly in bracket Feb actual is equal to Feb monthly 1. So we are picking the February figures, not February cumulative. So Feb actual is equal to Feb monthly 1, and then Feb monthly is equal to Feb monthly dot drop value, and we are also dropping YTD actual. So let me just try to print Feb monthly 1 first. You see how it looks like. Feb sorry, so here we print Feb monthly. I just print Feb monthly. You see what we have. So the period is 2 and the year is 2017. So when I print, you see we have three columns with numerical values. We have YTD actual. So this was coming from cumulative figure of January, and then you also have a value. So the value here is the Feb figures, the Feb cumulative, and then Feb actual are now the monthly figures for February. So whatever we've subtracted from value and YTD actual is what we are getting as Feb actual. So Feb actual is the monthly figures for February. And now we want to just remove the monthly figures for February, rather the monthly data for February. So what we'll do here, we'll drop this column for value and the column for YTD actual. Down here you're seeing I'm trying to, rather we've done a code here, return Feb monthly is equal to Feb monthly dot drop value and drop YTD actual. So when I print it down here, when I print Feb monthly, we'll see what we have. So again, the period will be period 2. It's a bit slow. So the period is 2, and then the financial year is 2017. So here we only have February monthly figures. So this is a data frame for the variable for February monthly. So after getting the Feb monthly figures, so now you want to change the Feb cumulative, the label for the values for Feb cumulative to YTD actual. So this value here was for Feb cumulative, but now we want to change it to YTD actual. So that's why we are saying Feb cumulative is Feb cumulative sum dot rename value YTD actual. Then from there, now we'll move to opening and closing stock, and we'll start with closing stock. So here we have our opening stock, and then the opening stock here we are saying that opening stock February monthly is equal to closing stock January monthly. So when we're doing monthly figures, it means that when we move January to February, the closing figures of inventory for January will be the opening figures for February. Rather, the closing figures for January for inventory will be the opening figures for January for February monthly. So opening, turn this one to blue again. So opening stock Feb monthly is equal to opening Feb monthly dot rename. We are renaming the column for January actual to Feb actual because the opening figures are the same. So what we are just trying to do to rename the labeling. So the labeling for January actual will be labeled February actual. And then when we go to cumulative sum, we are saying that now that cumulative sum, we have opening stock, opening Feb cumulative sum is equal to January cumulative sum. So the opening stock for January will be the same for all the years up to December. So when you have your period starting from March, it means that the opening stock for March will all be equal to the cumulative figures for each and every month until you reach the final period of the financial year, of which that will be Feb, your starting period of March. So the opening stock here will be the same for all the periods for cumulative figures. And then what will differ here is the closing stock for cumulative figures. So when we come down here, we also have closing stock figures. So here we are saying again that closing stock for Feb monthly is equal to Feb cumulative sum, where the ledger is equal to closing stock. So when we go here to Excel, when we come here, so whatever you're saying that the closing stock here for February, let me just take you back to that code. We are saying that the closing stock Feb monthly is equal to cumulative sum Feb monthly, where the ledger is closing stock. So we mean that the closing stock here is the closing stock of February. So when we go to March, the closing stock will be closing stock for March cumulatively. So but monthly it will be, or rather monthly it will be same, but the opening stock will be different. So here we are saying again that we are saying that closing stock monthly dot log closing stock is equal to closing stock Feb monthly Feb actual dot sum. So we want to get the last row after totaling the values of the closing stock. So let me just try to print this again. So when I print here CS, the CS of monthly, let me check if I have other printout tab. I don't have, so but let me print this. So here we are saying again that rather I want to see if how the data frame looks like after summing the values of the closing stock. So now we have here the last row here is closing stock, category is none, ledger is none, and then we have the values for total values of the closing stock. So the sum here, we've summed all these values here, so we are getting the total sum of the closing stock. So when you come up here, you can see we are having closing stock, or rather CS monthly is equal to pd.data frame. So we are trying to put this ledger into a data frame, or rather this data frame. Sorry, we are trying to put this variable data for this variable into data frame. So it's down here. We are putting this figure, not this one. This one is for cumulative sum. We are putting this monthly data into a data frame. So we have pd.data frame into CS 5 monthly. Then again we are trying to replace the not a number values with closing stock, and then we are writing here .tail to pick the last row. We are picking this last row for our closing stock. We are saying .tail in bracket 1. Then we are trying to reset the index. When we reset the index, this index column will come somewhere here, and then we'll have another index column starting from 0 up to the closing stock. And then when we drop the index column, so we'll do away with these values you're seeing here. Then we'll be having another index column with 0 up to the last. So from there now we'll have again the closing stock for cumulative sum, which is down here. So we are saying that the variable for closing stock for cumulative sum is equal to pd.data frame feb cumulative sum. Then we are getting a subset data of the closing stock. Then again we are getting the total sum of the values of the closing stock for cumulative sum. So here, and then we are saying that variable for cumulative sum is equal to CS cumulative sum to replace. We are replacing the not a numbers here, and then we are picking the last row, and then we are resetting the index to do away with this index that was having numerical values and the text value as closing stock, and then we are dropping the same index again. So when we print down here, you'll see we have a different data frames. This one will be not CS monthly, but this will be cumulative sum. Let me print cumulative sum. Let me print again. The period is 2. Financial year is 2017. So this is the closing stock for cumulative sum. Then again, let me try to print the monthly figures. CS underscore monthly of web again. So let me print. So this is 2 and this is 2017. So now you can see we have this is for the same figures are the same because the closing stock for monthly will be the same with the closing stock for cumulative figures for February. So the month, or rather the values will be the same, but the labeling will be YTD actual, and then this one for monthly will be Feb actual. So what we've done here for February will be the same principle will be applied to the other monthly figures and cumulative figures for the period March up to December. So when you come down here, we'll have March, we'll have April, May, June up to December, but the same principle that we've used up here will be the same principle we'll use from March to December. So let me just try to uncomment out March up to December. So we'll also uncomment this one out. Okay. So remember the same principle that we used in February. We'll use that principle when coming up with the variables for March, April, May, June, July, August, September, October, November, and December. We don't need to repeat that because the principle is the same. When we are subtracting, when we are getting rather the monthly figures, we'll get the previous cumulative sum of the previous period. Then we'll subtract it from the current cumulative sum of the current period to get the monthly figures. It's the same principle for all the years. So now when I call, okay, let me go up still. So let me do away with this. And then now, so these are variables for March. We have variables for April, which we have monthly figures and cumulative figures for opening stock and closing stock as well. So this will be the same principle up to December. So down here I can say print. So I want to print that's yes, December cumulative sum, and then I want to print yes, December monthly. The closing stock will be same. Yes, month, December monthly. So when I print, the figures will be same, but the labeling will be different for the values column. So here we'll have so it's taking long. So the period here will be 12. The year will be 2017. So now you see the YTD actual for closing stock is same as the YTD, the December actual. Again, if I write here OS instead of closing stock, I want to print opening stock. Let me just write as December cumulative sum. And I also want OS December. It's very slow OS underscore we want for monthly. Now when we run this code, so here the opening stock for cumulative sum and monthly sum. The opening stock for monthly and cumulative for December will be different as opposed to closing stock that are same. So here is 12 and then the period is 2017. So now you can see the opening stock for December cumulative sum is 807 and the opening stock for December monthly is equal to 711. So here it's writing closing stock because it is the closing stock for November, and this one is writing opening stock because the opening stock is same from January, February, March for cumulative sum up to December. So when we pick the opening stock for January, it will be same as opening stock for February, March, April, May, June, December for cumulative sum. But for monthly, opening stock will be different from January, different from February, different from March, April, May, June, up to December. So ladies and gentlemen, we've done the variables for current financial year. When we come to our next video, we'll do the variables for prior periods. Then next video will be the variables for a budget, and then we'll move forward and how to come up with financials. So let's stop at this point. So when we come back, we'll do the variables for prior periods. So thanks a lot for watching, and if you haven't subscribed, please do, and please also ask your friends to come so that we can learn together on how to automate financials using Python. So thanks a lot for watching, and let's meet again next video.